chooses to listen to what Verizon is telling it through its med fields, then it will choose the med path, the path that has the lower med. Okay? Any questions here? Yeah.
So would it just be a consideration of AT&T's part? Because it seems like AT&T would benefit from taking the med 50 route. Because it only have to have med into one. Why would it make that sense?
Yeah, great question. Hold on to that thought for just half a slide more. Same question? Okay. So exactly that question, which path or which route does AT&T prefer? And so Verizon said, I prefer the green route. That's what it did with its med field. But in this case, I think somebody said this already, if you're AT&T, you would prefer the orange route. Right? Again, under the assumption that we're trying to save our own bandwidth. Does this make sense to everyone? So what would AT&T do? Right? Ignoring meds, what would AT&T try and do in order to use the West Coast exit router instead of the East Coast exit router? It's clear to everyone why you want to use AT&T prefers the orange path? Right? Because the green path is consuming AT&T's own bandwidth across the country. So what could AT&T do? Yeah?
Make the internal links very high cost.
Right. The suggestion was make the internal links very high cost. The thing to remember is actually AT&T doesn't have to do anything to do that, right? We already have our intra-domain routing and our intra-domain costs. So if all I did was look at the intra-domain cost, so the IGP cost, and I said I got the same prefix advertised to me from two different routers, and when you're leaving Berkeley here, you look at what is my IGP cost to the exit router on the West Coast versus the IGP cost to the exit router on the East Coast, and you're just going to say, I'm going to pick the exit router that has the lowest IGP cost. This is something called hot potato routing, and everyone does it. So if you send traffic that's leaving the network, they will send it out of their network as soon as possible, unless you pay them. You pay the provider to carry your traffic further. So this is very common in cloud providers. If you, for example, sign up with Azure and you sign up for, you don't sign up for any special treatment in their network, then they will take, when your traffic is leaving Azure servers, they will hot potato your traffic. They will send it out of Azure's network as the first chance they get. If you pay Azure an extra fee, then they will actually carry your traffic across Azure's network until, as far as they can close to the destination. The assumption being that Azure is running a better network than the public internet. So what is IGP cost? Again, IGP costs are local to an AS, right? No one's going to advertise their IGP costs outside of the AS. And all it does is every router, what it does is when you get the same prefix advertised by two different border routers, you pick the border router with the lower IGP cost. Okay, so let's go back to that picture here now. And now I'm adding internal IGP costs to AT&T's network. And again, remember, these costs, private to AT&T. And it's not going to share them with anyone else on the internet. And now we're going to say that if you were this router over here, the orange one trying to get to Verizon's network, you would route through the border router on what was the East Coast in our earlier picture. If you were somewhere in the middle, you would just pick whichever one was the lower IGP cost. In this case, happened to be the one on the West Coast, or the one on the right. Yeah?
Why do the MD fields if, for example, if AT&T sends it back through the left router, what choice does Verizon have accepted?
Yeah, so that's, that was exactly the next point. So hold on, let's come back to see if you still have the question when we're done with this. So if you're looking at this, you should be thinking, wait a minute, this IGP cost is sending me in a different direction from what the med attribute was trying to say, right? So Verizon was using med to say, come in on the left router, not the right. AT&T is saying, I'm sending my traffic out on the left, not the right, because it's the shortest path. So IGP can conflict with med. This is not uncommon, this happens. And so, going back to that example we had, where Verizon was saying a med of 10 for the left and 50 for the right, well, in this case, AT&T is just not respecting the med. Is there a problem with this necessarily? Anyone think it's a problem? Yeah, so there might be some contractual back and bickering, but it does, nothing breaks in your route, yeah.
What I was trying to say is it a problem for AT&T, but there is some problem for Verizon because it takes more of their bandwidth?
Right, so Verizon can turn around and do the same. So in fact, this happens all the time on the internet. So for example, if you see two providers A and B and you're looking at traffic going between the east and west coast, what is quite common, for example, traffic going from B to a destination in San Francisco, B would immediately hot potato the traffic and send it over A's network. But the return traffic coming back from the destination to the source, A is also going to hot potato it and send it over B's network. Right? So everyone plays the same game. The point to notice here is that you have asymmetric paths. Right? Your path from a source to a destination may not be the same as the path back from the destination to the source. This doesn't necessarily cause a problem, but it does tell us why asymmetry on the internet is common. And it happens, by design, not necessarily as an accident. Yeah.
So if we're doing hot potato all the time, can't they cause a loop or they just send it back to each other?
So this is why I was asking, is there actually a problem? Like, could you get into a loop? How would you get into a loop? So the reason you wouldn't in this case, so let's take the green, right? You're going the traffic going from the source to the destination San Francisco. For A to send it back, the destination would have to be in B, which is not the case here. So you're still following an advertised path to the destination. So you're not going to have loops. So there might be some unhappiness between providers, and they might, get on the phone and talk to each other about it and massage their policies, but it's not causing your packets to be dropped or to loop. Any questions? Yep.
If all the ASs are doing IGP internally, what is the point of MVP? Except for migrating.
Great question. So you might ask, why bother with MED? Anyone know the answer? So what would have happened if the green source here was in LA, let's say? Still in B's network, but in LA. So on the West Coast. Would B have wanted to respect the MED field? So let's step through that. So the green source is on the West Coast. A has told B that it can reach the San Francisco destination. It's advertised that path over their link on the East Coast and their link on the West Coast. If I had no MED, B has no idea where the destination is relative to the East Coast or the West Coast. Right? So it would have no indicator for which one is the shorter path. In this case, it at least knows that, okay, the path on the left is actually the shortest path to the destination. So it's going to use the link on the left. Let me give you maybe a better example. Let's say that the green dot was in Ohio, in the middle of B's network. So going to the left or to the right, to the east or the west, is similar from B's perspective in terms of how much bandwidth it's going to consume. In that case, which way would it want to go? It would want to take the link that's closer to the destination because it's a shorter path for its own customers. Right? So the MED is a useful indicator when there is no conflict between MED and IGP. Great question. Okay, so closing the loop, our last lecture, we talked about how the typical selection policy, when you receive an advertisement, how do you select which path you want to use? And we said that the policies tend to be you want to make or save money. If they're equal in terms of making or saving money, you want to maximize performance, means take the shortest path. And then you want to minimize use of your network bandwidth. So you want to save network bandwidth to the extent that you can. You should now know, kind of in terms of mechanisms, how this is implemented. Make or save money is your local pref value. This is how we do Gao Rexford. Okay. Maximize performance, that's the length of your AS path. And minimize use of your network bandwidth, that's this dance we play between med and hot potato. Okay. So now when you think about how BGP is implemented, it should be very clear to you. This is kind of the table for how we apply attributes in a route update. Right? So how is BGP implemented? I get route updates. It has a prefix and a set of attributes. I follow the rules in this priority order that are in this table to decide which routes I'm picking. And everything we talked about, routing follows money, I want to have a good balance of performance, I want to save my bandwidth. All of that follows from applying these rules. And this is a priority order, that's the important thing to remember. I always first do local pref, because that's about making or saving money, and then I try to optimize performance and save bandwidth. Any questions? Right. So BGP clear? Okay. So let's talk about some limitations of BGP at this point. You've seen enough of BGP, what do you think? What are things that you think would work well in BGP or not work well? Where do you see potential problems in the protocol? I had 4 categories. Yeah?
It seems like an additional layer of work you have to do on top of IGP. You also have to handle the external connections, and maybe if you have a lot of different exterior routers, then that becomes more complexity.
Is complexity? Can I summarize this? Yeah, okay, we'll dig into that. Anything else? A broader view, beyond, yep.
Like the human cost of setting up like the routes and like loss.
Right. Human costs, I'm going to lump that in with, I think you're taking complexity to the fact that there's all this manual tuning. Maybe any other? What about security? Wait, I had 4 classes. How do people, thoughts on security? How could you imagine misusing BGP? Yeah?
A lot of entry and exit points, so more, I guess, that you have to secure against attack.
Points of entry that you have to secure, that's fair enough. More basic than that.
Can I act like a black hole that's sucking all the packets saying I will reach all the other data?
Right. So this is like a deeply problematic part of BGP. An AS sends an advertisement to you saying, I have this prefix and here's my path to the prefix. There is no mechanism in BGP to check that you actually have the right to advertise that prefix, that is actually a valid path to that prefix. There's just nothing in the protocol that is designed to catch that. Okay. There's also no guarantee that you say, maybe so you could lie about a prefix, completely spoof a prefix. You could also lie about the path. You could say, or not, choose to not lie about the path in the sense that you advertised a valid path to a prefix. Then when you got data packets, you just send them over a different path. You didn't actually respect the path that you advertised. So it's really just, this is an indication of how the internet was designed in a pre-attack, pre-security concerns era. The fact that there is just no validation or security checks around BGP. What would happen if an AS said, this is my prefix, I have this fantastic path to a prefix? If I just followed the BGP protocol spec. Yeah. Everyone just sends traffic to that prefix. So we call this prefix hijacking. Right? An autonomous system can claim to be any prefix it wants. So as you can imagine, in the real world, there are a lot of policies. Operators configure a lot of checks in order to make sure, is it strange that suddenly Google is being advertised only from Australia? There are all these sanity checks that go on to make sure these prefixes are valid. There are also protocol standards people are working on that would have cryptographic security around advertisements, so you can prove that you own this prefix, and you can prove that an advertisement traveled across a set of AS paths. But deploying them and getting all of that PKI infrastructure around it has been slow. So securing BGP is still